Hi everyone. A very good afternoon to everyone. Welcome to sixth session of Snowflake Educational Series powered by Bluepile. My name is Ayushi and I will be the host for today's session. In case you have missed on the previous sessions, please check them out on our YouTube channel. You can also find the link to the same on the chat box area. Now I would like to introduce today's speaker, Tanika Jindal. She is working as a senior big data engineer with BluePy and she handles various data warehousing projects. Today, she will be talking about data engineering in Snowflake. I hope you guys find this session informative. Please, uh, over to you, Tanika.
Thank you, Ayushi, for the introduction. Uh, Now I'll start. Uh, all right. So, hello everyone. A very good afternoon to all, and welcome to today's session. So, in the previous session, we talked about data lakes and how are they maintained in Snowflake. In this session, I will give you a high-level overview of how Snowflake Cloud Data Platform can be used to modernize data engineering workloads, improve data integration performance, reduce pipeline complexity, and consolidate all data at any speed. We will also do a deep dive into using Snowpark and DBT with Snowflake for all your data transformation needs. So, before starting, let's do a quick recap. In the last session, we learned what data lakes are and why are they needed, about their architecture, implementation styles, and best practices, and also how to implement data lakes via Snowflake. So, in today's session, we will start by talking about data pipelines. We will do a contrast between the two techniques, ETL and ELT, and we'll learn different ways to do data transformations in Snowflake, followed by a short demo on how to do the same via Snowpark and DBT. Let's start by talking about data engineering. So, data engineering refers to the building of systems to enable collection and usage of data. This data is usually used to enable subsequent analysis and data science, which often involves machine learning, amongst other things. So, this requires data pipelines. A data pipeline is a series of data processing steps, and if the data is not currently loaded into your data platform, then it is ingested at the beginning of the pipeline. So then there are a series of steps in which each steps delivers an output, and that output is used as the input for the next step, and it goes so on, and till the pipeline is completed, this series of steps happen. So in some cases, independent steps may be run in parallel, whatever be the use case. So data pipelines are the lifeblood of the modern enterprise. Your data likely deals with your organization probably has massive amount of data. So to analyze all that data, you need a single view of the entire data set. When that data resides in multiple systems and services, it needs to be combined in ways that make sense for in-depth analysis. Data flow itself can be unreliable. There are many points during the transport from one system to another where corruption or bottlenecks can occur. So, as the breadth and scope of the role data plays increases, the problems only get magnified in scale and impact. So, this is why data pipelines are critical. They eliminate most manual steps from the process and enable a smooth and automated flow of data from one stage of the data pipeline to another. So, they are essential for real time analytics to help you make faster and data driven decisions. Now, by consolidating data from your various silos into one single source of truth, you are ensuring consistent data quality and enabling quick data analysis for business insights. For data engineers, efficient data pipelines can be the difference between an architecture that delivers real value to the business and one that just becomes a burden. So data engineers need to be able to collect, transform, and provide data to the different lines of businesses while keeping up with the latest technology innovations to stay ahead of the business demands. However, with traditional legacy architectures, it creates some somewhat challenging situation for them at every step. So first, the data in various shapes and sizes is generated at different speeds. And with the legacy architecture, data lands in different databases, data lakes, data marts. Some might be on cloud, other might be on premise. So with resource scarcity comes performance degradation. Data pipeline performance suffers due to the prioritization of analytical workloads. This creates a bottleneck for both data integration and consumption. So, with complex, and also it has complex pipelines and architecture. If you're fetching data from various sources, it is bound to happen. So, data engineers spend most of their time configuring and managing that infrastructure instead of focusing on delivering data. Now, legacy and open source tools often require a specialized skill and custom coding, and it all makes data pipelines extremely time consuming to design and maintain. So, as a result of this, IT teams are stuck under a staggering amount of technical debt and cannot respond fast enough to business requests. And the analysts and the business decision makers are limited to incomplete and inaccurate data. With Snowflake's unique cloud data platform, every organization can collect more data than they could before, and it also simplifies your data pipelines and modernizes your data integration workloads in one single platform, and it works for both structured and semi-structured data. It also provides secure and governed access, thereby it delivers performance and scalability that the modern enterprises need. Also, it supports thousands of concurrent users without any resource contention. In addition to streamlining data engineering, Snowflake consolidates advanced analytics, data lake, and data sharing workloads into a low maintaining, easy to use service available across all three major clouds. With Snowflake and its partners, all of your data can easily be ingested through streaming or batch and securely centralized, making both structured and semi structured data available natively to your users. Now, pipelines can run on optimized, dedicated resources without manual configuration, and they can automatically scale up or scale down as needed. This drives to better pipeline performance and lower cost. Moreover, Snowflake leverages SQL to streamline pipeline development, reducing the complexity by not having to manage additional clusters and providing inbuilt capabilities to ingest data and manage pipelines. So, the first step, like we discussed in any data pipeline, is data integration. So, the ETL and ELT acronyms both describe processes of cleaning, enriching, and transforming data from a variety of sources before integrating it for use in data analytics, business intelligence, and data science. So, the letters stand for extract, transform, and load. Extract refers to the process of pulling data from a source such as an SQL or no SQL database, an XML file, or a cloud platform. Now, transform refers to the process of converting the format or structure of a data set to match that of the target system. And load refers to the process of placing a data set into the target system. Now, the difference between ETL and ELT is when transformation happens. So in the upcoming slides, we will do a side-by-side comparison of the two processes. First one is ETL. So ETL stands for extract, then transform, and then load. So in the ETL process, data transformation is performed in the staging area outside of the data warehouse, and the entire data must be transformed before loading. As a result, transforming larger data sets can take a long time upfront, but analysis can take place immediately once the ETL process is complete. The next is ELT, and it stands for extract, then load, and then transform. So, in the ELT process, data transformation is performed on an as needed basis in the target system itself. As a result, the transformation step takes little time, but it can slow down the querying and analysis processes if there is not sufficient processing power in your cloud solution. Now the question arises, which one is better? So there is no one answer to this. There is a place for each process. The ETL process is appropriate for small data sets which require complex transformations, and the ELT process is more appropriate for larger structured and unstructured data sets and when timeliness is important. So the shift from ETL to ELT has been underway for some time, and ETL pipelines have long been the standard of data integration since traditionally the target repository was a data warehouse. But ETL requires expensive hardware and regular IT support and takes longer for ad hoc analysis because the whole process must be repeated for every use case. Further, the ETL process doesn't support real time analytics or machine learning projects. These business needs, combined with modern cloud data architectures and today's agile development approaches, have accelerated the shift from ETL to ELT. Now, there are a number of pros to ELT as well. The first and the foremost being it provides a flexibility of data formats. So when paired with the data lake, ELT can ingest data in any format. There is no need to account for structures or schemas since the data lake accepts unstructured data. Also, in an ELT model, transformation typically happens only when analysis is needed versus transforming all your data before it's loaded, which means greater efficiency of resources. Then we have high availability of data. We already discussed how important high availability is for business in our second session of this series. So ELT supports that. With ELT, all data is loaded to the data lake, so it's always available. And this allows tools that don't require structured data to interact with the loaded data immediately instead of waiting until it's transformed. Also, the speed of loading is improved because transformation happens at rest. Data is loaded at the data lake as soon as it is available, and it provides immediate access to the information. And the speed of implementation is also improved because transformation is performed as needed, and the ELT model can be applied to new sources of data to quickly capture the information in the data lake while engineers determine the best ways to query and analyze that data. Now, Snowflake supports both ETL and ELT and works with a wide range of data integration tools. We have already talked about the extract and load part of the data pipeline in our previous session, where we talked about data lakes in Snowflake. Today, we will be covering how to perform data transformations in Snowflake. So, having ingested the data into a Snowflake landing table, there are several tools available to clean, enrich, and transform that data, and these are illustrated in the diagram that is on your screen. So the options available to transform data include all these five that we have on screen. So the first one is using ELT tools. So this often has the advantage of leveraging the existing skill set within the data engineering team, and Snowflake supports a wide range of data integration tools. Some of them are shown in the diagram, others you can refer to. You can go to the Snowflake documentation and find the list there. Also, you can use stored procedures. So, in addition to the APIs that Snowflake provides, it also has its own procedural language, Snowflake scripting. And this includes support for loops, cursors, and dynamic SQL, which is quite similar to Oracle's PLSQL. So, these features, when combined with the additional power of external functions and user defined functions, can be used to build and execute sophisticated transformation logic within Snowflake. Next comes incremental views. So it is a pattern that is commonly found on systems migrated from Teradata, and it uses a series of views built upon views to build a real-time transformation pipeline. It is anyways a good practice to break complex pipelines into smaller steps and write intermediate results into transient tables, as this makes it easier to test and debug, and in some cases can lead to significant performance improvements. Also, there are streams and tasks. So, Snowflake streams provide a remarkably powerful but simple way of implementing simple change data capture within Snowflake itself. So, it is a good practice to combine streams and Snowflake tasks on the data required for near real time processing effectively. The stream keeps a pointer in the data to record the data that has already been processed, and the task provides scheduling to periodically transform the newly arrived data. Previously, it was necessary to allocate a suitably sized virtual warehouse to execute a task, but the recent release of the serverless compute option further simplifies the tasks and means Snowflake automatically manages the compute resources and can scale up and scale out as needed. You do not have to manage that. Also, now you can use Spark and Java on Snowflake using the recently released Snowpark API. So, data engineers and data scientists who would previously load data into a Databricks cluster to execute Spark SQL jobs can now develop using Visual Studio, SBT, Scala, and Jupyter notebooks with Spark data frames automatically translated and executed as Snowflake SQL. So, combined with the ability to execute user defined functions, this provides powerful options to transform data in Snowflake using your preferred development environment, but without the additional cost and complexity of supporting external clusters. So, the data transformation patterns described just now show the most common methods. However, each Snowflake component can be combined seamlessly as needed. For example, through streams and tasks, we usually work with streams and tasks together, but they can each be used independently to build a transformation pipeline and combined with materialized views to deliver highly scalable and performant solutions. Out of the different ways that we just talked about, we will discuss Snowpark and DBT in more detail. Starting with Snowpark. So the Snowpark library provides an intuitive API for querying and processing data in a data pipeline. Using this library, you can build applications that process data in Snowflake without moving data to the system where your application code runs. So, Snowpark has several features that distinguish it from other client libraries. Firstly, the Snowpark API provides programming language constructs for building SQL statements. Although you can still use a string to specify the SQL statement to execute, to benefit from features like intelligent code compilation and type checking when you use the native language constructs that are provided by Snowpark. Also, Snowpark operations are executed lazily on the server, so it reduces the amount of data transferred between the client and the Snowflake database. So the core abstraction in Snowpark is the data frame, which represents a set of data and provides methods to operate on that data. In your client code, you construct a data frame object and set it up to retrieve the data that you want to use. For example, you might not want all the columns of a table. You select some columns, or you apply some filter to specific rows to get specific rows, right? So the data isn't retrieved at the time when you construct that data frame object. Instead, when you are ready to retrieve the data, you can perform an action that evaluates the data frame objects and sends the corresponding SQL statement to the Snowflake database for execution. This is very similar how Spark execution takes place. So you can create user-defined functions in your code, and Snowpark can push your code to the server where it can operate on the data. So you can write functions in the same language that you use to write your client code. For example, by using anonymous functions in Scala or by using Lambda functions in Python to use these functions to process data in your Snowflake database. And you define and call user defined functions in your custom code. Now, Snowpark automatically pushes the custom code for UDF to the Snowflake database. And when you call the UDF in your client code, your custom code is executed on the server where your data is lying. So you don't need to transfer the data to your client side in order to execute the function on the data. It stays within Snowflake. So there are some more benefit to Snowpark, like it supports push down for all operations, including Snowflake UDFs, and it does not require a separate cluster out of Snowflake for computations. All of the computations are done within Snowflake. Now let us dive into how we work with Snowpark in Python. So let me just uh, share my Jupyter notebook with you guys. All right. So the first step here would be to set up your development environment for Snowpark. Now, the Snowpark API requires Python 3.8, and you can create a Python virtual environment using tools like Anaconda, Miniconda, or Virtual ENV. For this demo, I am using a Conda virtual environment. I used Conda to create a Python virtual environment, and I added the Snowflake Conda channel and installed the NumPy and Pandas packages to it. Then I installed the Snowpark Python package into the virtual environment by using Conda. You can also use pip for the same. Also, you can specify packages that you want to install in the environment, such as if you want to use pandas, you can explicitly mention that as well. So once all that is done, you just install the Jupyter notebook and then you are ready to start. So I've already done all those steps prior to the session to save time. You can refer to the Snowflake documentation as well to get started. So now let's start. So I imported all the necessary libraries. After that, I mentioned all my connection parameters here to create a session while we work. Your account name, your username, your password, the role that you're using, the warehouse on which you want to work, the database that you want to access, and what schema of that database that you want to access. Then we created a session to run our queries. So uh, once this is done, we just check if the session has been created. So yes, it has been created. The current warehouse is test that we specified here. The current database is insurance fraud that we mentioned here, and the schema is public that we gave here. So everything works as planned. Also, you must have seen that I just put an SQL statement as string here and ran it. So you can do that as well using Snowpark. If you don't want, you can just copy your SQL statements in a string and execute those as well. Also, there is another way to do the same. So uh, just a second. So I'll okay. So in our Snowflake uh, insurance fraud database in the public schema, we can see that we have the following tables. Now we have a table called test claims and we have a table called test vehicle. So this claims table contains all the information regarding an insurance claim, and the test vehicle contains all the information that about the vehicles that have been insured. So what we do is we just we created a data frame by using this session, and we converted our test claims table into a data frame. Similarly, we converted our test vehicle table into a data frame, and then we join those both on the customer ID column to get a new data frame. So basically what we're doing here is we want to make out what claim has been filed for which vehicle. So to do that, we'll join it on the common key, that is customer ID. Once that is done, I'll write this data frame into a table. Let's call it demo table. So I execute this query, and it has been executed. Now, with these simple steps, I just joined two tables and wrote that data into one another table. Now we can just go to our we can just check it in our Snowflake database that a new demo table has been created, which would have the combined data of these two tables here. So it is as simple as that. You can perform other transformations as well by using data frames, or you can even paste your SQL queries here. Now, moving back to our presentation. All right. So, the capabilities of Snowpark are anonymous, which allows it to solve a number of user problems that are faced. So, some of the key potential gaps that Snowpark solves are that it offers developers the functionality of using Java, Scala, and Python to build code, and it allows businesses to migrate data by interacting with a simple API. So, if you want to perform some data migration task or something, you can just move your code state forwardly to Snowpark if it has been written in Java, Scala, or Python. Also, Snowpark provides the avenue for building application that link with Snowflake natively, unlike previously when code development and deployment would require separate infrastructure and maintenance to achieve this. Also, Snowpark reduces the long startup time for distributed resources where systems require clusters of nodes to carry out specific operations with it. But Snowpark solves this by connecting with Snowflake's virtual data warehouses directly. So you do not need to manage the infrastructure at all. Moving on to DBT. So, modern businesses need modern data strategies built on platforms that support data agility, growth, and operational efficiency. Now, Snowflake is the data cloud. It is a future proof solution that simplifies data pipelines. So, you can focus on data and analytics instead of infrastructure management. Now, DBT is a transformation workflow that lets teams quickly and collaboratively deploy analytics code following software engineering best practices like modularity, portability, CI/CD, and documentation. Now, anyone who knows SQL can build production grade data pipelines, and it transforms data in the warehouse leveraging cloud data platforms like Snowflake. Now, DBT comes in two variants: DBT CLI, and which is the command line interface, which is run by the terminal, and DBT Cloud, a web based application along with an IDE. The key features of DBT are listed here, so I'll go through them one by one. The first one is documentation. So, the documentation offered by DBT is updated as to when models are developed. It is also easily accessible throughout the development, and the documentation is generated based on the descriptions provided. So, dependencies between models, SQL files, sources, and the tests are defined. Also, it provides data lineage. So, the data pipeline in DBT is represented in the form of lineage graphs. This gives proper visibility of the data and how the data maps with the business logic. The complete flow of data from the source to the target system is shown in the graph, which provides transparency. And then there is version control. So, integration of Git with DBT has made version control come hand in hand. All the models, tests generated, sources, packages used, and other configurations used in the project are versioned in the connected Git repository. Then comes testing. So DBT comes with pre-built, unique but non-null integrity and accepted value testing. And SQL can be used to write custom test cases to add more testing features apart from the default tests. Uh, then comes reusability. So in DBT, it is possible to develop models that can be reused by using some framework. Also, uh, using DBT, it is possible to schedule refresh at the production environment according to the business requirement without the need of an orchestration tool. So you can orchestrate using DBT as well. So now the question is, why should we use DBT with Snowflake? Now, Snowflake is a data warehouse hosted as software as a service, which is faster, user friendly, and more flexible than a traditional data warehouse. Now, Snowflake's data warehouse is developed using a SQL database engine with an architecture specifically designed for the cloud environment. Snowflake is built using multi-cluster shared data architecture, and this makes the data storage and compute layer, the query processing layer, separated. DBT is an open source tool that is used to manage the ELT load in Snowflake, and DBT can be used with Snowflake for a number of features. Some of them might be like converting tables to views. So it is sufficient to change the materialization in a single config file to change a table to a view with DBT. Then comes stored procedures. The stored procedures created in DBT are shown in the models, which could be accessed and modified easily. Then is combining transformation logic. So DBT groups similar transformation logics together using DBT tags. Also, there is version control that we discussed. So DBT supports version control by integrating it with GitHub. And also, since DBT is open source, we can enhance the development by sharing experiences with fellow developers rather than starting anything from scratch. So it is one of the many perks that it has. Moving ahead, let's work on the integration of DBT with Snowflake and a little demo. Share my screen again. All right. So what you have to do is first you create an account on the DBT clouds. That's the first and foremost step. Then you go to your admin in Snowflake and go to Partner Connect. There you just type DBT and connect it here. I've already connected it. When once you do that and activate this connection, you'll get some credentials about what warehouse it is being used and some other credentials that would be required by the DBT cloud for integration. So basically, once you connect that, so Snowflake will create some other warehouse where you can work via DBT. Like when I connected, it created this DBT warehouse, Partner Connect DBT warehouse for me. Similarly, it will do for you. So once that is done, uh, herein you'll get a screen in which you connect to Snowflake and enter all those credentials, provide your account details there, and you can test the connection. And once you're connected with DBT, you can just name your repository and name your branch, whatever you want, and start with your coding. So the coding here is in SQL. You can just run simple statements like I'll just show you. So suppose we want to calculate the count of this test claim table. So just want to see the preview of what will happen if I deploy this. So you create models here, then you, okay. All right, I'll just compile it and then show you the preview. There might be some error. I'll try some other query. This was the query that we have that we ran in the Snowpark, the simple join that we did right on the two tables using the column customer ID. So once we did that, we can see that we got the result, right? There might be some syntax error with the previous statement. That's why it wasn't working. Nevertheless, so this query has been executed and it joined the two tables on this column customer ID that we had, and we got the result. So you can basically convert your data transformation into some SQL statements, be it complex SQL statements or whatever, and you can just execute them here. Right now, I showed you by executing just one statement, you can build a whole model like this and compile and orchestrate it. All right, let's move back to our presentation. Okay, so now when to use what. So both Snowpark and DBT have their own features, own pros and cons. So when you have to work with various programming languages like Java, Scala, and Python, you can use Snowpark. Versus when there is the people in your team are not that technically sound and uh, do not know these languages and are comfortable working with SQL, whatever be the reason, then DBT is a better way to go. Also, Snowpark is really beneficial while working with data science and machine learning model. It is secure, it is easily scalable. Versus DBT provides orchestration and there's documentation provided, so it solves a lot of problems there as well. So, choosing based on your use case, both of these can be a good option for you. Depends on what your priorities are, right? All right. Uh, that would be all. We can move to the Q&A. So, like Astha asked, what are streams and tasks? So, streams and tasks are some capability provided by Snowflake triggers. Using Snowflake streams, you can easily capture the change data. You can define if you want to capture change within two specific time periods or on a specific table, and that gets created as a new table. And Snowflake tasks can be used for scheduling your streams or any other stored procedure or any such things. So they are basically used for regularly scheduling a particular job. All right. So this is all for today's session. Since there are no more questions, we can end it. And also,
Okay. Thank you, Tanika, for such an informative session. And if you have any more questions, please feel free to mail us at the email address provided at your screens. Also, please provide your valuable feedback on the same email address. Please follow us on our YouTube and LinkedIn channel for more informative sessions like these. Thanks a lot for joining. Have a good day ahead.